My name is Bob DeMay, and this is my partner, Abhinav Joshi, and we're going to go ahead and describe to you a VDI solution that ensured business continuity during the snowstorms that ravaged the East Coast this year. Again, my name is Bob DeMay. I'm with Project Performance Corporation, which is part of AEA, an international consultancy. We specialize in project management, green IT, cloud computing. I've been with Project Performance Corporation for 5 years supporting government contracts. The last 3 years I've been supporting their virtualization efforts.
I'm Abhinav Joshi. I'm a virtualization and cloud solutions architect at NetApp. So I've been with NetApp for 2.5 years. So before joining NetApp, I was a solutions architect at PPC as well, and we together implemented the solution. So right now, my role at NetApp, so I'm part of a team that's responsible for developing the best practices or reference architectures on anything VMware in NetApp storage.
Why we're here. First, the solution we're going to describe to you has won a number of awards with the Telework Exchange Committee. Telework Exchange is an organization that helps eliminate roadblocks in implementing telecommuting. Now, how many of you are from the East Coast? How many of you suffered the snowstorms? How many of you are government workers? Okay. Office of Personnel Management has estimated that the federal government lost roughly around $70 million a day for each day it was closed. In the 4.5 days government was closed, they lost the equivalent of $315 million. They also estimated that it would have been $100 million a day, but there's a good chunk of government workers that telecommute. Some other benefits, and we're having a technical issue, sorry. Okay, some other benefits is this leads to green IT. The Telework Exchange estimates for 2,000 workers working from home 4 days a week that the agency helped eliminate about 10,000 tons of emissions. And then it decreases your total cost of ownership, and of course, you got less real estate, less electricity, less network resources, increases your return on investment. Okay, hopefully that's the only slide. Okay, the agenda. We're going to go ahead and discuss to you our approach, the business drivers. Then we're going to go into methodologies, the actual architecture and deployment. And then we're going to discuss some future trends. And at that time, we'll have enough time to answer any of your questions. Our approach. First thing we did, we sat down with the customers, the stakeholders, gathered their requirements, established the business drivers. Then we developed alternate solutions for them to evaluate. Then from there, based off of what matched their criteria, we went ahead and identified a solution. And then it was implemented in a number of phases. Okay, the business drivers. The biggest one is in 2005, Congress mandated that agencies needed to implement and have available a telework solution to 100% of the workers that qualify. The solution, another driver, need to address the growing workforce. The agency we worked for had 10,000 users working locally, and it was increasing 1,000 a year. And then we need to ensure business continuity. Our solution enables a distributed workforce, meaning people can work from anywhere at any time and still have access to their resources. Okay, this is supported for a 3,000 plus workforce. This establishes the groundwork for business continuity, and because of the phased approach, we were able to meet the government mandate. Okay, our challenges. Divided easily in 4 areas: business functions, network storage performance, desktop baselines, and application performance. Business functions, the attorneys were unionized. We had to meet the SLAs. Network storage performance, we had to estimate, did we have a capable infrastructure? Did we have enough network connections? Did we have enough bandwidth? Did we have the appropriate storage? Desktop baseline. At the time of this rollout, there was a number of different baselines. And application performance. The agency had 192 custom applications. The majority of them had it hard-coded to point to the C drives. So in order to meet the mandate, we could not do folder redirection. That was too many applications to redesign. So therefore, we had to increase the amount of C drive space for the VMs. Okay, our solution. The solution needed to have the same look and feel of what they were used to working with. Collaboration. They needed to be able to still, even though they're working from home, be able to still work with each other. And support. No longer did the end user was going to have the ability to pick up the phone and have someone from the help desk knock on their door and fix them. So we needed to provide them extra training so they could support themselves. This also meant we needed to change a lot of the SOPs. Okay, our solutions. I'm going to go over the alternatives and our analysis. Then I'm going to go ahead and go in particular to the ideal solution and how we planned it. Okay, first alternative was the rack and stack. We took the user's physical PC, moved them to the server room, and they were able to access that PC via RDP and VPN. Unfortunately, this was a one-to-one connection on the network, and it took up a lot of real estate. Blade servers. We already had a couple blades in-house. It achieved high density, meaning you did not need that big a footprint in the server room. However, you still need the one-to-one connection for network connections. Terminal server. Another business area was already using Citrix. It consolidated a number of users can connect to few servers. Okay, and it allowed for ease for bare metal restores. However, it did not have the same look and feel of their desktop, which was one of the requirements. And then virtual desktops. We already had VMware on site for server consolidation. Technology was cutting edge. This added a feature to be able to centrally manage the VMs. Okay, here's the little scorecard. This is rack and stack. You could tell the footprint. Those were the actual racks that we used. How much space the footprint that rack took. Okay, it allowed us to meet the government mandate, but it would not allow us to address the growing workforce. It would be too expensive. Okay, blade servers. Even though the footprint was smaller, you could tell each blade needed its own network connection. Okay, so if we were still using blade servers at this time, that means we needed 3,000 network ports in the server room to be able to manage this. So to address the growing workforce, it would have been expensive. Okay, terminal server, we would have met the mandate, but since a lot of the legacy apps needed a lot of hands-on, we didn't meet a number of SLAs. And then VDI solution. To ensure that we properly developed this, we would not have met the mandate. But as you can see, it met the majority of the requirements. Collaboration is something, and we can see it on the next screen. None of them met. The software, the voice over IP software that we were using would not work over RDP. So the examiners were issued government-issued laptops, and the software were installed locally. Okay, so because of this, to meet the mandate, we had to go into a stage approach. The first stage, we went ahead with the rack and stack. It was easy, little training was needed. It was just moving their physical hardware to a different location. It was expensive because of the footprints in the server room and the network resources. But this allowed us to properly develop a VDI solution which leveraged the existing vendor, VMware. Okay, reduced our cost. It did require some additional training for support. Okay, as you can see here, we see 4 phases. We actually have a 5th phase, phase 0, which was our proof of concept for 250. But the solution required 2 different fronts. One was the virtual side, one which is the storage management side, which Savinoff will be talking about shortly. Okay, here is the basic. It's not a true VDI. We're not using a connection broker to prevent confusion on the end users. We went ahead and kept it with the VPN RDP connection, and they RDP through the DMC into their VMs. Okay, the first display was the 2.x VMware 2.x. We had 3 separate VLANs. We went ahead and was using to host the VMDKs. We were using NetApp. What was that? 6080?
No, 980. NetApp
980.
Yeah.
I'm sorry, I couldn't see the screen. And then for our home shares, was using the 3050s. Basically, what this is showing is that the users, if they're hoteling, coming on site, or working from home, they had access to the same resources. Okay. Also, the network configuration on this, we were using Nortel, trunking and tagging. Okay, with the 3.x world, we upgraded the Nortel to Cisco. This allowed us to use VSS, which allowed us to provide bigger pipes for the virtual machine networks. We eliminated, I forgot to mention the management pieces. As you can see, we had LeoStream in the 2.x world, and that managed and helped with the P2Vs. IP switch, what's up, allowed us to monitor the terminal server support. So that way we could be proactive. If a VM came up but the terminal services didn't start, we'd know ahead of time. 3.x world, we eliminated LeoStream because VMware Virtual Center now manages all that. Okay, we went ahead and upgraded the VMDK host to the 6080s, but the home directories were still hosted on 3050s. Okay. Now, what's in the future? What we're looking at? Automation is one of the key things. NetApp has a couple utilities. One is rapid deployment, which would allow us to rapidly deploy VMs within a matter of minutes. Application performance. As I told you, with IP switch, what's up, allows us to monitor the network port. Well, we need to look at some other alternatives to be able to monitor the applications. That way we could be proactive and catch the problems before the users call. Chargeback. We need to be able to hold the business areas accountable for what resources that they were using. Okay, capacity planning. We need to ensure that we could expand without affecting SLAs, and we'll be able to project what we need when we will be required to do an upgrade. And then everybody's favorite word, the cloud. All these key things will allow us to go to the cloud environment, which would allow us to do desktop as a service. Okay, Abhinav.
Sure. So in the next few slides, I'm going to talk about how the storage architecture evolved over the period of time. So as Bob mentioned earlier, we started the POC back in 2005, and the architecture evolved as there were a lot of lessons learned in the project as we scaled from, say, 100 users to 3,000 and beyond. And also there were a lot of new requirements that were added in the solution, so we had to change the architecture around that as well. So phase 1 POC, so it was a POC with, say, 100 users. So both the C drives and the user data were hosted on the NetApp storage arrays. So for hosting the C drive, so back then, Fiber Channel was the only option available in terms of the transport protocol. So we had the C drives on the Fiber Channel on a FAS 980, and then for the user data, it was hosted on the CIFS home directories, also on the NetApp storage array. In terms of the backup requirements in the POC, so the requirement was to only back up the user data hosted on the SIF's home directories. Because the plan was to implement the folder redirection and the ROM profiles, so that way we don't have to back up the C drives. Now, these are the key reasons as to why NetApp was chosen as the storage vendor. The unified storage capability resonated extremely well with the customer. So using the same OS and the same set of tools, the system admins are able to manage both the SAN and the NAS. So they do not have to learn different tools or different OSs in order to manage the SAN and NAS. And NetApp has a record of success in the SIF's home directory solution. So this was a natural fit in the VDI environment as well. And this actually allowed the user to also get the self-directed restore. So that way, the users can have a SIF's amount, say a share, and they're able to drag and drop the files if they need to go back in time and do any kind of restore. So that way it helps out a lot in terms of dealing with the help desk tickets and makes the process extremely simple. The next key capability that resonated extremely well with the customer is that NetApp is actually able to pool a large number of physical disks and then create a large virtual pool of IOPS and capacity that can be used on demand, say, by any VM in the environment. So most of the questions that I get asked by the customers is that how many IOPS do I need to size for in terms of the VDI environment? That's actually a very difficult question to answer, and there is no standard because each of the user is a different individual, and it also varies, say, from department to department, right? So virtualizing a pool of IOPS and the capacity helps out a lot. So that way, any of the user can use the IOPS available for the entire spindles in the pool. And the last thing I want to highlight is the data protection capability associated with the NetApp storage array. So the customer was in the process of evaluating, say, 2 storage arrays. So the first one had RAID 5 and the RAID 10 capability, and NetApp had the RAID DP. So RAID DP is actually equivalent to RAID 6, but it does not have any performance impact. So in terms of the RAID 5, right, so if you are virtualizing a lot of users in the environment, so RAID DP is only, say, RAID 5 is only able to protect you against the failure of a single disk in a RAID group. And the failure of the disk is a definite mathematical certainty. So if you lose 2 disks in a RAID 5 config, so a lot of your users are going to be offline, and that could result in a lost productivity. So then the customer looked at a solution that would have RAID 10, like in order to protect against the double disk failure. But then in that case, the cost of the solution would have been extremely high because the customer now has to buy double the amount of storage. So the RAID DP capability actually protects against the double disk failure. So this is proprietary to NetApp, right? So it actually provides you the resiliency comparable to RAID 10, and it comes at the cost of RAID 5. So you get best of both the worlds, and there is no performance impact in the environment. And the last thing I want to highlight is the snapshot capability. So the snapshot backups are built into the storage array. So that way you don't have to install an agent inside each of the VM and do a file-based backup. So the backups are block-based, and so in a VDI environment, so since you have, say, hundreds or thousands of users, so managing the clients inside each of the VM is going to be challenging, say the daily backups. So the snapshots are built in the backup, and they also have the capability to provide you replication and remote retention as well. So there were some lessons learned in the POC phase that I want to highlight. So the major thing was that we signed up a total 100 users. But at no point in time, so there were more than 60 users logging into the solution. So there were a lot of political reasons for that. So if you do a POC in your environment, so make sure that the users who actually sign up are in fact using the POC, like the VDIs in the POC, because that will help you get the performance data and help you size the storage for the production deployment. So in terms of the IOPS, so we were not sure if the IOPS number that we got out of the POC are high or low, because like only 60% of the users actually logged into the system. So back then, there was no recommendation available in terms of the sizing of the storage, so how many IOPS you need to consider. But now there have been a lot of advancements in the technology, and there are a few vendors that actually offer the VDI assessment tools that you can actually have in your POC. So that will give you an estimate of what the desktops are actually doing and what applications are actually consuming all the IOPS. So a couple of the vendors that I see most of the time in the customer environments are Liquidware Labs and Lakeside Software. So if you do a POC in your environment, definitely have a VDI assessment tool if you want to size the solution right for the production environment. And the last thing I want to highlight, the lesson learned from the POC is that since we had a lot of legacy applications in the environment, so if we had to recode like all these applications to make sure that they don't have the hard-coded paths into the C drive, this would have essentially meant that we have to wait for 2-3 years before all the applications can be made compliant. So since we had the eGov mandate, so the decision was actually made that we have to find a way to back up all the C drives. And the decision was actually made after the POC, and the storage purchase order had already been put in. So based on the POC and all the lessons learned, this is how the architecture evolved. So we had the same thing, fiber channel SAN for the C drives, and then CIFS home directories on the NetApp storage array. In terms of the backup, so the decision was made to use the storage array snapshots, say for the backups of the C drives as well. So the customer was debating between the installing an agent inside each of the VM and do a file-based backup. That would have meant 3,000 agents and then a whole new backup infrastructure to manage. So this actually proved to be more efficient in the environment. So let's talk about the challenges in the phase one. So the first key challenge was back then, so there were no tools available to balance your LUNs across the different paths onto the storage array. So it was a manual process. So each of the LUNs, so based on the topology in the environment, you had to manually load balance all the LUNs in the environment. So like right now, NetApp has a tool called Virtual Storage Console, so it can actually help in making sure that your LUNs are actually balanced across the different paths onto the storage array. So if you don't have the NetApp in the environment, talk to your storage vendor. So I'm sure they'll have a multipathing tool as well in the environment. But this is extremely important if you're scaling the environment out. So you have to make sure that all the pieces of your network infrastructure are in fact being used. The other key thing I want to highlight is that the storage on the backups of the C drives. Right. So based on the POCs, so all the storage for the backups was actually bought for the CIFS home directories. Right. So right now we were dipping into the storage that was purchased for the backups of the user data, and we knew that we cannot continue on that path for a long period of time. And the third piece, as Bob mentioned earlier, was there were a lot of SOPs that had to be changed, because as you move the desktops into your data centers, so in terms of managing all the help desk tickets, so now you have to involve your teams in the data center as well. So in this case, like the example is the storage team was actually managing all the backups now. Since the backups are built into the storage, so the storage team had to manage. And there were some changes in the SOPs as well. And then after the POC, or say phase one, so there was a new requirement added. So the customer actually wanted to move all the backups off-site as well, like to a bunkering facility 300 miles away. But the customer did not have a lot of funding, and they had some existing storage arrays that could potentially be used in this environment. But they did not know like how to use that. So they had some third-party storage arrays available and had a lot of capacity available. So we had to find a way on how we could transfer all the backups off-site and be able to use the storage array. So a decision was made to implement a NetApp V-Series device that would actually virtualize the third-party storage arrays and use the native NetApp SnapMirror capabilities to move all the backups offsite. So this actually proved to be a very cost-effective solution. So the customer only had to buy the gateway devices and use the existing storage arrays in the environment and had a DR solution for all the virtual desktops. Let's talk about the scale-out challenges in the phase 2. So in the phase 2, we scaled to 1,500 users in the environment. So the first challenge that we had was, so now since we have a lot of desktops in the environment, so there were performance issues associated with the read IOPS. So specifically associated with the boot and the login storms and the AV scans, and then so each of the user had quotas as well, say quarterly quotas. So in the last 2 weeks of every quarter, so they used to use the desktops a lot. So we were actually seeing a lot of IOPS burst activity in the environment. In terms of the write IOPS, the customer did not have any issues in the environment because the solution was already optimized to handle all the write IOPS. So NetApp has the capability to coalesce multiple write operations coming from the clients and then push them onto the disk as a single IOP. So that actually proved to be extremely valuable in this environment. The third key capability was, so we were running out of storage because on the backup side, because all the storage for the backups was actually purchased for backing up of the CIFS home directories and not for the backup of the C drive. So the customer wanted to find a way in order to use or say the existing storage, say for backing up the C drives as well. And as always, funding was a big issue at that time. So let's talk about all the enhancements that we made in the solution as we scaled out to the 3,000 users. So the first thing the customer did was to manage the read IOPS burst. The customer implemented the NetApp performance acceleration modules, or now called as the flash cache. So this is actually a read cache, and it's deduplication aware as well. So it helped the customer eliminate all the read storms in the environment, and the customer was able to better manage all the AV scans, all the boot storms, the login storms, and also help improve the end user experience in the environment. The next thing the customer did was they implemented the NetApp deduplication capability on the backup device, and immediately saw 80% savings in the environment. So that way, the customer was actually able to eliminate the future purchases of the backup device, like in order to back up the C drive. So they saved a lot, and now the customer did not have any issues in terms of the storage on the backup device. And then, as the customer scaled out to 3,000 users, so they were seamlessly able to upgrade the storage arrays from an older model onto a new model. So this would allow the customer to scale out to well beyond the 3,000 users, right? So in terms of the downtime, so it was actually a very simple head swap, and the total downtime was like only 2 to 3 hours. So that was very compelling in the customer environment, and they were extremely happy on how the upgrades actually went. So I'm going to show you. So here, so as I mentioned earlier, so the PAM card, so the flash cache, was implemented only on the 6080 that had the VMC drive. The customer did not have to implement the PAM cards on the storage array hosting the user data. And then the dedupe helped save a lot on the backups. And the NetApp SnapMirror is actually dedupe aware as well. So that way, all the savings that you see on the backup device are actually available on the DR site as well. So the data is not rehydrated. So the 80% savings on the backup device are actually transferred onto the DR device as well. So last I heard, so the customer is actually taking off a couple of the third-party storage arrays, say, from behind the V-Series, and using them on a separate project because of all the savings that the customer saw in this environment. So this actually helped them to save a lot on this project and also avoid any future purchase on a different project. So let's talk about the challenges from the scale out of phase 3. So, so as I mentioned earlier, the customer has the fiber channel SAN environment. So as we scale to 3,000 users, so it was becoming extremely hard to manage the environment with, say, more than 400 LUNs, and then like all the zoning and the cabling and the masking. Specifically, they were having a lot of issues in the troubleshooting of the SAN environment. Since in each of the LUN, the customer had like 8 to 10 VMs in each of the LUN. And also, in terms of the cost of the infrastructure, there were 200 ESX hosts and then storage arrays. So the cost of the infrastructure was actually going to be very high, like as the customer continues to scale well beyond the 3,000 user mark. Then, since each of the desktop consumes the storage, so the cost of the storage was actually going extremely high. So the customer had to buy a lot of storage if they had to scale beyond the 3,000 users. The third thing I want to highlight is, so in this environment, the system admin is actually asked to provision 50 to 100 VMs at a time as the new users are added into the environment or as the users leave. So the provisioning of the VM using the traditional cloning is a very time-consuming process, right? So each of the VM has to be cloned using the VMware cloning, right? So there was a 4 to 5 day SLA, say for enabling all the 50 to 100 users. So that was extremely inefficient in the customer environment. So they wanted to find a way to be able to rapidly provision all the VMs. So now in terms of the phase 4, so the customer is in the process of implementing phase 4 of the solution. So they are in the process of migrating all the users from the fiber channel SAN onto NFS, in order to save costs. So this would help them to save a lot on the network infrastructure. Last I heard that, because of migrating onto NFS, the customer is able to reduce the cost of the network infrastructure by more than 70%. And the customer is also in the process of implementing the deduplication on the primary storage arrays. So because of that, they are able to avoid all the storage purchases on the primary storage. So using the existing storage, the customer will be able to scale well beyond the 3,000 user mark. In terms of the provisioning, so the customer is in the process of implementing the NetApp Flex clone and also the VMware Link clones in the environment. So that would allow the customer to rapidly provision the VMs, and the VMs are going to be space efficient from day one itself. So all these enhancements in the solutions are helping the customer to reduce the cost, to increase the operational agility in the environment, and also improve the scalability of the solution. So these were the results of the implementation. So the customer is able to successfully migrate, say, more than 3,000 users into VDI environment, and also has a robust backup and a DR solution, and also ultimately it's able to support the Go Green initiatives and be able to meet the eGov as the mandate the customer had. So that's all we have. Now I'd like to open up the floor for any questions and answers. Are they persistent desktops? So the question is if the desktops are persistent or non-persistent, right? So actually, a majority of the desktops are persistent desktops, and they have a few non-persistent desktops as well. So it's actually 80-20. So 80% persistent and 20% non-persistent.
Reason is because since the since the legacy apps have to write to the C drive, they can't erase the data.
During your POC and your initial adoption of virtual desktops, did you build desktops clean and migrate users onto a fresh desktop with the apps installed, or were you working with P2Vs for the original one?
P2Vs. Basically, because of the requirement that they need to have the same look and feel, that was the way to get us to there without affecting the user.
Did you run into any problems
No. But remember, with the 2.x, we had to use LeoStream. We had to use the third-party tool to help manage that. Good.
Are you creating a separate network for your NFS traffic?
Yeah, it's a separate Ethernet network. So that's actually dedicated to the storage infrastructure. So
You were asking if that means we had to have extra network cards for NFS?
no, each of the VM has only a single NIC. So the teaming is actually done at the ESX layer. So each of the ESX host has 2 NICs, and you team them and you put them in a virtual switch. That's how we implemented.
And the NFS traffic was on separate cards? Yes.
How are you going to be migrating your SCAN data to your NFS data?
Right now, so the customer is actually using the storage vMotion to migrate the fiber channel data into the NFS.
Is that live in production during?
Yeah, so they actually try to do it in the evenings or say in the nights. But in some cases, they also do it during the production hours. Since the storage vMotion is a seamless process, so it doesn't have any downtime involved. Like if you have to migrate the data from like a protocol A onto the data stores from the other protocol.
Have you noticed any performance hits going from fiber channel to NFS?
No, the customer has not seen any performance issues, say from moving from the fiber channel onto NFS. Actually, the performance of all the protocols is like the same, and we have a lot of papers that actually prove that the performance of iSCSI, NFS, FC, FCOE are like all the same in a virtualized environment.
NFS, though, with NFS, it has given us to be able to manage it more. We can extend the LUNs without having to bring the VMs down.
But
versus
data
VMF,
storage.
right. With the current VMFS LUNs, you'd have to move them over to bigger LUNs. This we could expand hot. Go ahead.
Sure.
I'm curious, when you added the read cache to improve the latency, how did that speed things up in the absence of deduplication? Because when you're booting or doing antivirus scans, everything read like once.
Yeah, so like all the data is actually read only once, right? So in each of the controller, so the customer added say 2 PAM cards, right? So that actually provided some extra cache in the environment. And now the customer is in the process of implementing the deduplication on the primary storage array. So that would further enhance the performance of the solution. Does that answer your question?
I'm just curious how it did make it faster. I mean, if you're reading everything just once,
Right.
caching it shouldn't speed it up. You still have all the traffic from the disk to the cache and to the cache.
Yeah, so the PAM cards, right? So you load the data into cache only once, and then like all the reads are happening directly off the cache. So you don't have to go back onto the spindle.
Back there?
With about 3,000 VDI desktops, I'm just wondering how many read and write IOPS the storage has to face. I think that most of it will go to the tab module. That's why you added it.
Right.
But, is there anything you can say about how many thousand IOPS are needed to host such an environment?
Yeah, we actually have the sizing tools that can help you compare that if you don't have the flash cache or the PAM cards in the environment as compared to if you have the PAM cards in the environment. So based on all the sizing and the customer deployments, I've seen that because of the PAM card, so the customer is able to save say more than 50% on the spindles.
How many IOPS do you need to host this environment?
So I've seen, say kind of varies on the user type. So I've seen that the numbers anywhere from 8 IOPS to 12 IOPS. And the read-write ratio actually varies during the day as well, or say during the month as well. Say in the morning, say when all the users are logging into the solution, right? So it's going to be mostly read IOPS, right? And then say during the day as they actually work, So it's going to be half read and say half write. So your storage array should be able to efficiently manage both the read IOPS and also the write IOPS.
Yes. How many VMs are you putting on each NFS?
Right now, the customer has like about 200 VMs on each of the NFS data store. Between 100 to 200. Some of the data stores have more and some have less.
How many VMs per CPU in this environment were you able to consolidate?
Because since we started in 2005, there's a number of different hardware versions. Back in the first phase, actually the first two phases, we used, what was it? It was 4
Dell, PowerEdge 6850s, and each of the ESX hosts had 16 VMs because it was a single CPU, said dual core, so we could not put a lot more.
Now the newer one have eight cores. We left it at the 16. Okay, but we're just in part of the expansion, which is currently being done. We're adding more to that. Actually, we're planning on adding 24 per host. Yes, sir.
Sure.
Are you using a separate network card for your NFS traffic and using stuff like jumbo frames?
Yes. Yes to all that. We ensured the Cisco, when they went from Nortel to Cisco, they ensured that jumbo frames was enabled across board, and we had to manually create the virtual switches to enable the jumbo frames. Yes, sir.
Who does first time synchronization on the client side?
We're using VMware tools and have, yes. We're using VMware tools to sync with the host, and we have it disabled in the operating system. Anybody else?
Further to that, what was the reason you chose that one rather than disabling the VMware tools time synchronization and sticking with VD time synchronization?
I have to find that out. I wasn't with the original deployment. I don't know if there was time syncs with issues between the domain controllers, but if you leave your card, I'll find that out for you. Anybody else? Well, thank you very much.
Thanks a lot. Have a good time.
Thank you.